So we're going to be talking about rewriting equations from standard form, and we're going to take them to slope-intercept form. Okay. So again, we have two forms of the equation. We have the standard form, which looks like this: ax plus by is equals to c. And on that, the a, b, and c are constants. Constants are just any numbers. Okay, it could be any number that you can think of. And the x and y are the variables that will remain like that in the equation. So, for example, an equation like in standard form is 3x plus 5y is equals to negative 20. Okay, in this example, a is 3, b is equals to 5, and c is equals to negative 20. Okay, and it always looks like this: the x, then the y is equals to the number. Okay, whereas on this other one we have the slope-intercept form, which is on y is equals to mx plus b. We've talked about this one. The m represents the slope, which is usually the change on y over the change in x. And b is the y-intercept. Okay, let's look at this example. Okay, so again, our goal is to take this equation in standard form and write it in slope-intercept form. So we want it to look like this: y is equals to mx plus b. Okay, that's what we want. That's what we want to do with this. Okay, so on this we're gonna get the y by itself. Okay, so to do that, I have my two sides of the equation, and the first thing that I'm going to do is I need to move the 2x to the other side. So since it's positive, I'm going to do minus 2x minus 2x. That is a zero pair, so it goes away. We're left with negative 3y. It's equal to negative 2x and 18 are not like terms because this one does not have the x. Okay, so we're going to do negative 2x plus 18. We can't combine them. Okay, so I almost have y by itself. I still need to get rid of the negative 3. We're going to now divide both sides of the equation by the number, so negative 3. So divide by negative 3. Everything. Divide by negative 3 and divide by negative 3. Okay, so this one cancels out, and I'm left with y by itself. Negative 2 divided by negative 3 is going to give me positive 2 over 3x, and 18 divided by negative 3 gives me negative 6. Okay, so in example 2, I have 4x plus 2y is equals to 6. So what I want to do is get y by itself. Okay, so that's the goal. Because if I have the two sides of the equation, right? Now, I don't want the 4x and I don't want the 2 in there. I want all of that to either be on this side or not at all, so that it's not on this side of the equation. Okay? So (4x), that one is a positive. Okay? Since I don't have a negative in there, that tells me that 4x is positive. So what I'm going to do is subtract 4x from both sides. Okay? Now, when I do that, I have 4x minus 4x. If you remember from last semester, what do we call those two? Zero pairs. Remember? In a zero pair, when we do that, they zero each other out. So we can say those are out of there. We no longer have them. So we only have 2y on this side, and we have it's equal to negative 4x plus 6. So my new equation is now 2y is equals to negative 4x plus 6. Okay, so I'm going to divide everything by 2. Okay, so divide that by 2, divide this next term by 2, and divide this last term by 2. Okay, it's important to divide every single term in the equation. Okay? So once I do that, 2 divided by 2, it's just a 1, and we don't need to write the 1, so I can just put y by itself now, which is what we wanted to get to all along. Y is equal to negative 4 divided by 2, negative 2x, 6 divided by 2 is 3. And that is my equation in slope-intercept form. Okay, so we went from standard form to slope-intercept. We do this because sometimes when we're working with systems of equations, they're going to give you equations in standard form, and they're going to ask you to graph it. But in order to graph it, you need to have it in this form. So it needs to be in the y equals negative 2x plus 3, so that we can determine what's the slope. So from there, I can see, okay, my slope is negative 2 over 1. And then my y-intercept is 3. Okay? So again, we go from standard form to slope-intercept form so that graphing it becomes easier and we are able to identify both the slope and the y-intercept. In example 3, I have negative 5x minus 4y is equal to 20. Okay, and again, this is in standard form. I want to put it in y-intercept form or slope-intercept form. That way I can identify the slope and the y-intercept a lot faster and better. Have the two sides of the equation, and I want to get y by itself. So we're going to add 5 to both sides. Since I have minus or negative 5x, I want to do the opposite of minusing or subtracting, which is adding. So plus 5x plus 5x. Okay? And now that I have that, this becomes a zero pair. And zero pairs go away. We no longer need them. So that goes away. I'm left with negative 4y is equal to, since these two are not like terms, I cannot combine them. So I'm just going to leave them like that. 5x plus 20. Okay? Okay, so we're going to divide every term by negative 4. So divide by negative 4, divide by negative 4. Wait, why did I put 5? Four, and divide by negative 4. Okay? So these two cancel each other out. and I have y is equal to 5, and divided by negative 4, I can go to decimals. And if you don't know what that is, what 5 divided by negative 4 is, you can always just go there and it will be easier, okay? So 5 divided by negative 4 gives me negative 1.25. Okay, but we always want to put the fraction, so we click here, and it gives me the fraction form, which is negative 5 over 4. So going back to the note page, that's what I'm going to write. Negative 5 over 4, bring down the x, and then 20 divided by negative 4. Again, if you don't know what it is, you can always use this and not stop. Negative 5. Okay, so minus 5. Now that I have it in this form, if I were to graph it, then I can identify the slope, which is negative 5, that's the change in y, over 4, the change in x, and my y-intercept, negative 5. And it's a lot easier to graph it.